Hey everyone, it's Ange from They Keep Bees. We had a lot of technical hiccups at this past Monday's class 2 of online Queen School. So today I'm going to record the lecture that I gave so that it can be received in continuity with clarity. And then I'm going to include in the email a link to the audio only of our Q&A from Monday night. There are a lot of rich and dynamic questions, and I want to make sure that everybody gets the benefit of hearing my answers to those. So I'm going to kick us off by sharing my screen. So as I said, I'm Ange. I am one half of the collaborative effort of They Keep Bees. At They Keep Bees, we work at the nexus of social change and social insects. We raise adaptive queens and produce honey, wax, and educational resources. Our practice utilizes responsive and natural methods of beekeeping that are easily adaptable for small-scale and backyard beekeepers. We love to teach about bees. This is our website, which many of you have been on if you're signed up for this Queen School, as well as our Instagram and Facebook handle. And our email, if you want to reach out to us, is info@theykeepbees. So it's always important for me when I'm giving any talk to just ground in who I am and where I'm from. So Ange, I am a non-binary beekeeper. I use the pronouns they and them. I am from New York City, so I'm not your average intergenerational beekeeper. And I think that perspective allows me to see patterns and opportunities in ways where folks who are mired in something for many generations may not be able to. I am of Ukrainian heritage. This picture all the way on my right is me and my grandma at the beach. We shared a love for the ocean. I love to share about bees with other beekeepers like we're doing right now. And I also really love to share all of the social lessons from honeybees with people who might not know that much about bees. So I've given a TED Talk called What Bees Can Teach Us About Shaping Change, which you can find online. And then I run this little bee business where we raise and sell queen bees who are adaptive to the 2 bioregions in which we work. So we work in the Northeast in what is now called Western Massachusetts and Vermont. And we work in the Southeast in what is now called the Central East Coast of Florida. I don't do this work on my own. Like the bees, it is collaborative community work. And so in this slide, I'm just acknowledging that. I work with my partner, Bee Klein, who you see in some of these images working hives with me. And then I also collaborate with my buddy, Sam Comfort. He is a mentor and a collaborator on a lot of the research I'm going to share with you today. Sam Comfort also made the Comfort Hive, which you'll see in a lot of these slides. It's a small 12-inch by 12-inch box with an 11-inch diameter internally. It's a small hive, and I've got more pictures of it that I'll show you and I'll describe a bit more. At They Keep Bees, I said we are migratory beekeepers, so we move between the Northeast and the Southeast. We work with adaptive queen genetics in both of those bioregions, selecting for queens that are adaptive, resilient, and selecting for longevity of queens, so queens who survive and thrive through several seasons. And we also select for bees who display varroa-sensitive hygienic behaviors and can thrive under varroa pressure. We do move bees, and I want to just acknowledge that. This image is of us actually packing up bees to move up coast. And what we like to do is move our mating nuke hives so that we can dequeen and requeen those with the genetic material from each of the 2 bioregions. So what you see in the back of this van, whose name is Vandalion, the trans van, she likes to move bees up and down the coast. And what you see in there is our mating nooks that we're moving from Florida to Massachusetts so we can begin the queen breeding season up there. This is our home apiary in Western Massachusetts. It's right in our yard. And this is one of our primary mating yards. This is also going to be the site of all of the hands-on queen rearing lessons that we do this summer from May until August. And we'll talk a little bit more in detail about that towards the end of the presentation. And this is one of our primary mating yards in Florida. This one has gotten a little bit bigger since this picture. I think there's maybe 3 times as many hives here now. And we've gotten a little more savvy about weed control here too. But these hives you'll see are in lots of different formats. So we do work prominently with the Comfort Hive style hive, which I'll talk about in a moment, but we also use top bar hives and we use 5-frame nucleus hives. And we're really working with all styles of hives. And I came up over the last decade as a Langstroth beekeeper. So we're familiar with all of these systems and have tried our methods in all of these systems as well. But for us and our goals and objectives as beekeepers, we really do lean towards the use of the Comfort Hive for both mating queens and raising our bees up and overwintering them in 2 locations. So they keep bees. We work with queens and we produce queens in 2 bioregions. This is a queen bee for those of you who may never have seen or held one before. This is one from our Carniolan line of queen bees. They tend to be a little bit darker or stripy on the sides, like you can see on this queen. And we also produce honey. A lot of the honey that we produce is through crush and strain methods. So we cut these combs off, crush them and strain them to produce liquid honey, or we cut these combs off, cut them, freeze them, and then sell them as comb honey. So that is a small market for us, as well as the wax that we cull from these hives and sell to other makers and craftspeople. This is just an inspection of the Comfort Hive, and I'll link to a PDF of this presentation because this is a nice little inspection. You can also find this on the Queen School tab of the They Keep Bees website, where I take you through describing the brood nest of a Comfort Hive, where the honey, nectar, and pollen are stored, where the young bees and brood are stored. And so if you're interested in understanding the dynamics of this type of hive, that would be an excellent little video for you to watch. Comfort hives are not Langstroth hives. And so they are, as I said, these 12-inch boxes, 11-inch diameter inside. We use bamboo skewers as our top bars, or quote unquote frames. There's no frame to this box. It's just a simple top bar. The bees draw wax down from those top bars and they create their own natural bee space. Bee space is when the space for one bee to pass another bee back to back without friction. And bee space is important in any hive because it's important for the bees caring for and tending to the wax comb, moving easily through the space to store nectar and pollen and tend to brood, which is the nurse bee's job. And it's important to maintain that bee space because if that bee space is a little squished or bees can't access part of a hive, that leads to the potential for small hive beetles or wax moths to be able to get into that area and really thrive and capitalize on the opportunity of bees not being able to access and protect that part of the nest. In a Langstroth hive, you have 2 little cleats at the end of your frame, and the cleats, when pushed together so that they meet, actually make the bee space naturally for you. In Comfort hives, we have to actually make that bee space by using a visual indicator inside of the hive. Again, just a visual looking down into a Comfort hive, and we're gonna look at this box several times throughout the presentation so we can talk about how we make splits and then add queen cells to them. So hopefully these visuals will help it make sense. But here you can see the space between the combs is enough for 2 bees to pass without creating that friction. There are 8 combs in a hive. And this image is from what Sam Comfort calls the 1.0 Comfort hive. It had bar rests internally, which you can see at the top and the bottom of this box. It's what the bars are resting on. And we've since, or Sam has since done a double skewer, long skewer, uncut, that lays over the top of the box. And that double skewer allows for a longer comb to be built in a double box, so a Comfort Hive 2.0. And a lot of these cleats are getting removed. If you follow us on Instagram and see some of the They Keep Bees work, you'll see a combination of both hives with the bar rest and hives without the bar rest, because we are in a transitional process of transitioning all our bar rests out. There's no good or bad way. If you prefer the bar rests, that's fine. They do create a little bit of a challenge when you're trying to cut the little bit of attached comb off the sides of the hive, and they can create the opportunity for more squished bees. So making a transition away from them is making inspection a little bit smoother, and making the human and honeybee relationship a bit calmer. Okay, so now I'm gonna just switch gear to talking about how we work these hives. When we are working our hives, we are trying to use the natural impulse to swarm to push our hives to expand and then make lots and lots of splits. So we are working responsively with these hives to capture and encourage this sort of like swarming impulse, right? And then we are going to give new queens to each of the small splits, mimicking a hive that is left behind after a swarm to raise a new queen. And in this way, it's a bit more natural and responsive to the way that swarms reproduce. Here's me just brushing this swarm into a box. Another great way to tend and catch bees. So when we first started working with Comfort Hives at They Keep Bees, we had gotten from a friend of ours 3 tall Comfort Hives, like what you see here. So 3 boxes tall. I think we bought about 20 of them to establish our hive materials inside of Comfort Hives rather than making a transition from Langs to Comforts. There's lots of different ways that you can make that transition. And maybe we can talk about that more in a future iteration of Queen School. But we bought these, it was the late winter going into early spring in Florida, and we needed to split them. And so, and at this point, each of the boxes had those bars in it with the bar rest, right? And so the way, okay. The way that we at They Keep Bees decided to split these boxes is doing drum or smoke ups. It's either drumming or smoking from the bottom of the hive. You see here, I'm putting a shim in the bottom of the hive between the bottom board and the hive body. And then I'm smoking with my smoker, big, white, billowy plumes of smoke from the bottom of the hive to the top. And what I'm trying to do here is get both the bees and the queen to begin to run, right? Because they're going to be running away from the light and the smoke. And particularly the queen is going to start that running, and then many, many of the nurse bees are going to follow her. And then a lot of the flying bees are actually going to end up alighting into the air. The smoke up is, or drum up, is an old way of splitting hives so that you could drive a lot of the bees into a box on the top. Here's that box that I'm putting on the top. And then what I'm going to do is cover that box up with a lid. There we go. And then I'm going to smoke or drive the bees up into that empty box. What that's going to leave us with is this. It's going to leave us with a huge cluster of bees. And in that cluster, we're going to be able to find this beautiful lady, a queen bee. So this was a fairly effective way for us to split our hives, to cut the boxes apart without crushing and killing a lot of bees, to find the queen and make sure that she's safe, and then to take the hive and split it into several boxes. So we could take one large hive and make several small hives. This is an example of what it looks like when we split those boxes up. These boxes can get a queen, freshly mated, like we saw in the previous slide, or they can get a queen cell. In the second box, we have 2 frames of brood and 2 frames of food on the external frames. And into this box, we would also want to shake maybe 1 or 2 frames of bees so that we have bees surrounding those combs and keeping the inside of the hive well protected. into those splits, we're going to drop these cells. And each of these queen cells is what they're called, has a virgin queen inside. In this particular image, you'll see a virgin queen chewing her way out of one of those cells. And by placing this virgin queen in a cell into a split and allowing the queen to go out and mate, what we're getting is a brood break, a break in the brood cycle in the hive. And we're getting a small mating nuke or small hive that can grow up into a larger hive. It takes about 10 days to 2 weeks, depending on where you are and the weather and conditions, for this queen to mate and to begin to lay eggs in that new hive. That hive can then be grown up, or you can start this cycle again and place a new queen cell into that hive. So this cycle is one of the ways that we produce queens. It is a way that we get brood breaks or breaks in brood of broodlessness inside of our hives, and is a way that we expand from a few large hives to several small hives, and then have the opportunity to grow those up over the course of a bee season from spring into fall, and put more hives into the winter so that we can expand our apiary, which has been important to us because we are slowly expanding and growing our apiary numbers so we can produce more queens, wax, and honey. But we held a lot of curiosity about how we could make this process of rearing queens more accessible. We taught a lot of classes about queen rearing, but we really were holding curiosity about what are the ways that raising queens can be simplified and sustainable for small scale apiaries who aren't looking to grow hundreds of hives over the course of a couple of seasons. And what we found is that these 10-day cells, while they are excellent for production and the rapidity at which we are trying to grow, they don't necessarily offer as much of a brood break as if a hive swarmed, or if you did a swarm or walkaway split. And so we started asking questions about what it would look like to try different strategies for producing queens. And we went back to the queen rearing calendar. We know that an egg from the egg that is laid all the way through to the queen being mated and laying capped brood takes about 38 days. And that means that if we take the cells out of a hive at 10 or 11 days and we put them into mating nooks, that we're really shortening that span of time by about half, right? Which is great, again, if you are producing bees for sale, but maybe less optimal if your objective is to get brood breaks. So what are the ways that we can teach methods and also encourage brood breaks that are going to drop down the Varroa infestation in a hive? So whether you are a treatment minimal or a treatment-free beekeeper, you can access the capacity for your hive to create a brood break, which is going to encourage these beautiful, abundant, healthy hives with minimal treatment, which is really what we're looking for. And in this image is that Comfort Hive 2.0 that I mentioned, and maybe this is a Comfort Hive 5.0 on the far end. No, it's a Comfort Hive 2.0 that's been combined. But these boxes of bees have had multiple brood breaks in a season and then are left to grow up with a lower Varroa count going into the late summer, fall nectar flow, and seize upon that nectar flow to grow the winter bees that they need to go through winter in either Massachusetts or Florida, and be productive, healthy Varroa-resistant bees. And we're definitely seeing results with these strategies because you can see the brood pattern on the picture all the way to my right. Is quite beautiful, and also is there's got a few chewed out combs, which indicates that they have found or scented Varroa in those spaces and are uncapping the brood to release the Varroa. So we went back to grafting and larva, and thought about ways that we could make this process a little bit easier. Now, grafting is tricky. You have to be able to pick up the tiny little squishy larvae that are in the second and third row up from the bottom. Okay, so you can't graft eggs because they're too fragile and they'll just explode. But you can graft with a very small tool these tiny larvae that are young and C-shaped. And they ideally are 24 to 48 hours old, and they are all able to grow up into a healthy and abundant queen if fed the right diet of royal jelly and pollen. So how do we teach this? How do we simplify it was our question. First, we started by trying to just teach classes about grafting and queen rearing. And we've always had great success in filling these classes and bringing people into the apiaries and engaging in this strategy for grafting cells and raising queens. But grafting is difficult. It takes a lot of practice to get good. It takes optimal conditions for what's called a cell raiser, where you put these tiny little larvae to thrive. And there's a lot of opportunities for things to go wrong. You could take too long to graft the larvae and they dry out. You could not have a well-built cell raiser and your graft fails. So there's a lot of opportunity for error, especially when you're learning. And though as professional beekeepers, we are grafting hundreds and hundreds of these cells every year, maybe thousands at this point, it's taken a lot of practice and a lot of failure to get good at that. And one of the primary places, along with the grafting and cultivating that can go wrong, are the cell raisers, right? So this is a cell raiser. I'm going to show you this. This cell raiser is queenless. So there is no queen in this hive full of bees, right? It is a 10-frame Langstroth hive. On the bookends of the hive, I have 2 frames of nectar. So 2 on one side, 2 on the other. That's 8. Nope, that's 4 frames total. Then I have a frame of dry pollen next to that. And then I have several frames of capped and emerging brood, not any open larva at all, because we know from some research that if there's open larva, bees will tend to tend to their open larva and ignore your grafted larva, right? So in our cell raisers, we typically like to make them up by taking a double 10-frame hive, Langstroth hive, like you see here, breaking it down into a 10-frame box with lots of nectar and pollen inside the box, as well as that capped and emerging brood, no open brood at all. We shake that down, it's completely queenless in here, and we leave, depending on how many we're grafting, 1 or 2 of these grafting frames. We graft onto those frames, like we saw previously, and then we place them inside of this abundant cell raiser. And the objective of the cell raiser is that they are going to care for this larva, tend to it, and raise it up into those 10-day cells that we saw earlier. We come back 10 days later, we take those cells out, we place them in mating nukes that we made up, the queens hatch, and they emerge. These cells are it's really crucial to have these cells be well fed with that royal jelly. And so this is one of those cells actually at day 5. Royal jelly is important because it's all the queen has to eat while she is pupating in this cell. And she is going to eat it up when she's a little larva, and then she's going to pupate. And then before she hatches, she's going to turn around and eat the rest of it. So you need enough for the larva, and then you also need enough for the queen right before she hatches to get that vitality and energy to be able to hatch out of the cell successfully. And so cell raisers are a key component of the success of queens. And there are some incredible beekeepers in the world doing just bee magic, as far as I'm concerned, with cell raisers. Michael Palmer is one of them. He's got something called brood factories. He's got massive cell raisers. And every cell I've ever seen at Michael Palmer's apiary looks beautiful. The Mixas in Florida are another family doing incredible work with raising queen cells. But this is a cultivated practice. those cells, again, they're going into these splits like we see here on the right, and then they're going to hatch out and become queens that either can be put into a new hive or raised up in the hive they're currently in to go through the winter. So how do we simplify this? How do we make this more accessible? One way that we thought about was raising 48-hour cells. Now, if we go back to our cell raiser and we think about the bees have to be in here the cells have to be in here for 10 days. And during that time, if there is a dearth of nectar, if a virgin queen from another hive flies into this hive and mates and starts laying, if there is a worker that decides to become a laying worker, you can lose all of those cells, right? So all of the work that you put into rearing these queens would go kaput, and you'd go back to ground zero, grafting again. So we asked this question about what are the ways that we can make this process simpler? And we came up with two ideas. The first idea was something called 48-hour cells, as I said. And the next idea was finding out how to make a high quality queen from a walkaway split. And our question in our initial research with 48-hour cells and walkaway splits was, can we make high quality queens from these two alternate methods? And so what we did is we compared 10-day cell queens, 48-hour cell queens, and walkaway split queens. This is some of the research materials that we produced from those lessons. You can get these free at the They Keep Bees website. If you go to the Queen School tab, you can download all of these documents for free. They feature our results. They feature recipes for walkaway splits that we're calling the runaway split. And they feature a step-by-step guide to how to raise queens using any of these methods. All of this research supported by Northeast SARE, that's Northeast Sustainable Agriculture Research and Education at the University of Vermont, and some of this research in partnership with the University of Massachusetts in Amherst. Okay. So instead of 10-day cells, that we saw earlier, we wanted to make these 48-hour cells, and we wanted to know if they could be successful. Here's me celebrating a perfect take of 48-hour cells. 48-hour cells would come out of the hive at 48 hours or 2 days, and they would go into your mating nooks. Walkaway splits would just get a minimal amount of resources necessary to raise a queen, and then they'd be responsible for raising these natural queen cells. Here's an image of one of Sam Comfort's mating yards with the Comfort hives. I think this one is in North Carolina. Yep, there's some tulip poplars there. And could we produce these high quality queens using these two methods? That was our initial question, right? Can we do it? Got to start there first. And we're not selecting these queens for color. We're really just figuring out, can bees raise high quality queens using these alternate methods and simplify this process a little bit? Now, how did we evaluate these queens is a great question. We did two things. We did field data, which I'll talk about in a moment, and then we did lab data, which is when we caught queens. We caught about 15% of the queens from the study. We sent them over to the Tarpey lab at Western North Carolina State University, and they evaluated these queens for their morphological traits and their the quality of the sperm in their spermatheca. As I said, from that, we produced this guide called Raising Queens, a how-to guide to sustainable queen rearing. And again, takes you through every single step. I'll show you where to find it towards the end. So what do we do for methods? We produced mating nooks and placed cells from our 10-day grafts, our 2-day grafts, and walkaway splits, right? So we didn't make cells for the walkaway splits. We just made up little splits, walked away, and let the queens do the rest. Oh, and then we came back at day 30 to check and see if the nook had a laying queen, if they had mated successfully. I've said this word a couple times, or this phrase, queen quality, right? What do I mean when I say queen quality? Queen quality refers to a queen's reproductive potential or her ability to lay lots of viable eggs that will grow into healthy bees. Why does that matter? Because we want queens who can survive, who have the longevity to thrive in the environments that they're in. Queens mate during a 2-week window after they emerge, and then they store that sperm for the rest of their lives. So the amount of sperm that they store and the viability of that sperm is actually really important for understanding whether a queen is of high quality. The conditions of rearing affect sperm storage. The younger a larva, when she begins to receive a lavish queen diet, the more queen-like she becomes. She's bigger, she's better developed, she has longer reproductive organs, and thus is able to store more viable sperm. More complicated queen rearing methods like the 10-day graft give beekeepers more control over larval age and nutrition, and theoretically more control over queen quality. Well, that's what we thought before, but our thinking has been challenged with the study, which is exciting. Okay, I want to talk a little about field data, lab data, right? So in our initial study, on day 30 days after we had placed our 10-day cells, our 2-day cells, and our walkaway and made our walkaway splits, we came back and we looked at 314 queens. And we asked, was the queen in the hive successfully mated? Was she there and was she laying eggs? Yes or no? Very simple. Then we looked at the worker population size in the nook. Was it small, medium, or large? We quantified this because we wanted to know if there was an impact in using 2-day cells or walkaway splits, because there's a longer period of broodlessness. Would that lead to a smaller population size? In which case there may be issues further down the line with the nook being able to make it through the winter because they don't have quite the population they need to collect nectar and pollen for the fall flow, or they don't have quite the population they need to raise all the bees they need for going into winter. So these two factors rose to the top as things that we wanted to measure when we were doing field data. We also looked at lab data, which is the morphological features of the queens, the weight and the size. And then again, as I said, insemination features, the amount and the viability or quality of the sperm stored in the queen's spermatheca. You ready for our results? Okay. Of our field data, there was no significant statistical difference between the 3 methods, the 10-day, the 48-hour, and the walkaway, which tells us that in those 3 methods, queens came back to the hive well mated 66 to 68% of the time. Nook population, or the population of that nucleus colony, we saw, again, no significant difference, slightly lower in the walkaway splits, but we could mitigate that with additional feeding or combining some of the walkaway splits in to increase their vitality. Then in the lab, we looked at queen size and mating characteristics. So again, no significant difference between the morphological grade and no significant difference in the mating characteristics or like how high the insemination grade was. And what's cool about sending these to the Tarpey lab for this type of evaluation is that they measure, they literally dissect and measure several different parts of the queen, including her abdomen, her thorax, her head, her legs, her wings, and they compare her morphological qualities to every queen that they've ever evaluated at the lab. So your comparison of how high quality your queen is to every commercial backyard beekeeper who has ever sent a queen to this lab, which is pretty cool. And the same thing with the insemination grades. No significant difference in the insemination grade and high quality insemination for each of our queens, which was so exciting for us.
So then we took a deeper look at walkaway splits. And so in collaboration with Anarchy Apiaries and Sam Comfort, Sam made over 500 walkaway splits using several different methods, because we wanted to really drill down into what makes a good quality walkaway split. What are the factors from the field that we can compare to see what impacts they have on raising a high quality queen? And then, can we actually get a recipe, please, for how to make a good quality walkaway split using the least amount of resources necessary to do so? So that's what we did. We made all of these splits, and we had this database of different qualities that we were comparing. We looked at the density of population. We looked at comb age, we looked at brood age, we looked at moving and even isolating and sealing and then re-releasing walkaway splits. So sort of sealing the bees in and putting them in cold storage and then taking them out and opening them back up. And we wanted to know how to make a high quality walkaway split. And from this, it was pretty exciting to find some pieces of field data that rose to the top. And it was also exciting to see that there's a fairly simple way that we could make walkaway splits. And this is a Sam Comfort coined term, the runaway split. And as I said, on our website, They Keep Bees, you can find the recipe for runaway splits. You can watch a video if you click on that little yellow box right there. That takes you through the process of making a runaway split, or you can look at this really cool little hand-drawn recipe for how to do so. So the first thing you do, I'll go over the data points in a second, but I really love this recipe. So you move the whole hive to a new spot in the yard. No, it does not matter where. Just don't put it right next to where it was before, because the bees are going to drift to the queen scent. But move the whole thing, right? If you have to keep it on the same pallet, turn it 180 degrees so it's facing the opposite direction. Then you can take an empty hive box, place it where the original hive was, orient the entrance to where the original hive entrance was. Now, from your original hive, you're going to go over there and you're going to move one frame of larva and eggs with the adhering bees, no queen, and one frame of comb of nectar and pollen with the adhering bees, again, no queen. So you've got 2 frames in there, and what you have returning to that original location is all of the forager bees who are going to be able to tend to and feed the walkaway split cells. You're going to leave that, run away, and you're going to come back in 4 weeks or 30 days, and you're going to check for a queen. At this point, your hive will have started building new wax and recovered from the brood break, and you should find a queen inside of that hive. And you have a couple of options. At that point, you can take the queen out and make another walkaway split, or you can expand it for honey and going into the winter wherever you are. This process of letting the bees make their choice of what the best queen is, making bees choice queens, it disrupts the pattern of needing to graft and needing to learn that technical skill. And that's not to say that the technical skill of grafting isn't valuable, but it is to say that an entry point into queen rearing is understanding what it takes for a hive to raise a queen and raise a high quality queen, and experimenting with this recipe in your apiary so that you can begin to build your understanding of bee math and build your confidence in understanding the mating cycles of the queen. You can also build your confidence in understanding what's happening in a hive while it's raising a new queen. And then maybe you do want to graft. The other cool thing about walkaway splits, is that they allow for that brood break, as I said, but they also increase the diversity in your apiary. When you're grafting, you're not increasing the diversity. You're selecting from one queen and you're grafting 30, 60, 100 cells from that one queen, right? And so all of those hives are going to be the daughter of whomever your breeder queen is, which is great if you're trying to propagate this varroa-sensitive hygienic or the traits of that queen that make her good. But what if you have 10 really great queens in your apiary and you don't have time to graft from all of them? Okay, cool. Make some walkaway splits. You've now maintained the diversity of your apiary and you have daughters from all 10 of those queens. So in case they swarm or they die or they crash, you have access to all of that daughter genetic material, and you have access to your other breeder queen, your queen that you grafted from. So it's really giving you like 2 nodes of access for making high quality queens that you can retain the genetic diversity in your apiary. We all know that in ecological systems, genetic diversity is key to a system thriving and surviving and adapting to change. So knowing that, this creates an opportunity for us to take advantage of that and continue to propagate high quality queens while getting brood breaks. I want to just talk about some of the things that rose to the top as relevant from our field data. What we found in our field data is that the most successful splits had a medium density of bees. So this was 71% of the hives had a successfully mated queen. They they had this medium density, and this is the volume of bees to box, right? What we found with the stronger hives, the overcrowded hives, is that they had a slightly lower success rate in mating, and with the weaker hives, also a slightly lower success rate. What does this mean? Maybe a medium density hive is just slightly less crowded, allowing for the bees to easily move across the comb and draw down the queen cells. Maybe it deserves further investigation because it's about the age of the bees specifically. But this density finding is interesting because we've always assumed that it's the strongest hives that make the best queens, and this challenges that assumption. I like having my assumptions challenged. Okay, next we looked at the mating success based on comb age. That's the next little chart over. So what we found is that splits with new comb were 73% successful at bringing back a mated queen versus old comb only 56% successful. The hypothesis here is that newer comb is easier for the bees to work and draw down into wax cells. Older comb is more brittle and a bit more difficult for the bees to work and draw down into wax cells. And if you've ever seen a queen cell being formed on an older comb, sometimes they're set way back in the comb, and then the bees have to draw the cell way down, and that may make it more difficult for the queen to access the royal jelly that we talked about earlier. And so these factors tell us that having younger, newer comb in our boxes could impact the success of our walkaway splits. And that's also congruent with what we've learned over time about how bees store chemicals and detritus from the outside world inside of the hive, inside of old wax. So it may be beneficial for us to continue to make, to cull comb more intensely if we are trying to have sustainable and treatment minimal apiaries. Mating success based on brood age, what we found is that when we gave hives eggs and a mix of young larvae and eggs, they had the most mating success. And that that tracks because they need that young larva to make a high quality queen. If the queen is too old, if she's third, fourth, fifth instar, meaning the days old, then they're not going to be able to raise her into a high quality queen that has the proper nutritional and morphological traits to be more queen-like, right? And so often those queens that are raised from older larvae, they'll be small and sort of chubby and stunted. Their spermatheca doesn't develop quite as well as what we understand. And they don't have the longevity that we're really looking for in our queens. So it really behooves us to give eggs and mixed larvae, and that shows a higher mating percentage rate. Finally, we have a moving splits, and this is reflected in the recipe, right? So the last table is all about moving the split. And what we found is that when the hive stays in its original location, and there is no move at all, that there's a high mating success, or when the hive is sealed up at the end of the day and taken to a new location. What that tells us is that the returning and foraging field force of bees actually impacts the capacity for the hive to raise a successful queen and keep the hive fed throughout the duration of time that they're raising the queen and then feeding her and the new and emerging brood. So we recommend either, as we say in the runaway split recipe, allowing for that hive to stay in the original location, or put it in the original location, plug it up at the end of the day, and move it to a new location in the evening so that you don't have quite as much drift of the forager bees. So I just gave you a really abbreviated summary of 2 studies that took 2 beekeeping seasons. So we did this work in 2019 and 2020 beekeeping seasons. If you want to read more about these studies, you can. We actually wrote full scientific reports about our methods and our results. And you can find both of those reports on the Sustainable Agriculture Research and Education page under the Projects tab. And you can search our names, so Roell, Sam Comfort, or you can search these project titles. You want to write these down. The first study about 48-hour cells, 10-day cells, and walkaway splits was called Identifying the Most Effective and Accessible Queen Rearing Methods to Strengthen Northeast Beekeeping Practices. And the second one, all about the best way to make a walkaway split, is called Testing Darwinian Honeybee Breeding Protocols for Mass Replication, Evaluating the Efficacy of the walkaway split as a queen rearing method. Yeah, I'm just looking to make sure. Yeah, so you do need to actually search one of our two names or these titles, because we at They Keep Bees had a rebrand, and so they won't be listed under They Keep Bees, but will be listed under Sam Comfort or Angela Roell if you're looking for it by name, or you can find it under these titles. So what do we do with all this research, right? We spent 2 years collecting data, evaluating queens, sending them to labs, looking at field research, and now what? Well, the now what is literally what you're sitting in. The now what is building a culture of beekeepers who are confident and proficient at using these different strategies to raise high quality queens and are able to implement these strategies in their home apiaries. So what you're sitting in is online queen school. That is happening or has happened in January, February, and will happen in March and April of 2022. And then again in January through April of 2023. So these are 8 opportunities to listen to beekeepers who are raising queens in all different styles and methods, how they're doing it, what they're doing, what their practices are, what their stories are, and how those things weave together. We want to give you an opportunity to hear from a diverse array of speakers, and we want to give you an opportunity to hear about, our research and our stories, but also beyond that, what else is out there and what else is happening, what are best practices. And so all of these online classes are completely free and accessible just by filling out the registration link on our website. And you will get all of the recordings if you sign up for one. You've signed up for everything. It's a really simple way to access and follow along with what's going on. And then we have Generative Bee School, a queen rearing series, which will start in May of 2022 at They Keep Bees Apiary in Montague, Massachusetts. And there we're going to focus prominently on teaching you these 3 different methods: walkaway splits, 48-hour cells, and 10-day cells. At Queen School, you're going to get to graft multiple times. You are going to get to practice making walkaway splits. You're going to get to catch queens, take some of those queens home, and you're going to build community with other beekeepers who are committed to queen rearing as a way of creating sustainable and generative apiaries. They Keep Bees and Anarchy Apiaries are collaborating on this project to put it together, and we're also going to be bringing in some of our guest speakers from Online Bee School and some other featured guest speakers to come to the apiary and give lectures to participants. With the online version of Queen School, it's a simple sign up. You just got to sign up on our website. With the in-person, you'll also receive notice if you signed up for any portion of Queen School, and there's a simple application you'll have to fill out. We do have limited space in these classes. They're going to be very low cost, sliding scale, and there will be scholarships and travel stipends for folks who are on the lower end of that sliding scale, because it's important for us that this be accessible for all beekeepers, and that it create opportunity for new beekeepers to come into the practice and feel supported and held regardless of where they're coming from. So at the end of March, after our March 21st online class with Melanie Kirby, we will be announcing the enrollment for 2022 Queen School. So if you're interested, just stay tuned, keep it locked. Mark us as not spam in your inbox so you get lots of notice about what we're doing and how we're rolling that out. With this Generative Queen School, we're also going to create a listserv or Google group so that we can continue to stay connected as a community and talk to each other and ask questions. We're really excited about the possibility of that being more, but right now it feels most tenable for us to be able to moderate a listserv where we can at least begin conversations and then see where it goes from there. So yeah, we are really hopeful that you will join us for all of these Queen School classes, as well as the hands-on version. And as I said, we're going to be doing this in 2022, so this year. And we're going to be doing it next year too. So it gives you lots of time to plan for this year and for next year. If you want to be a part of this and you want to learn a little bit more about all these different queen rearing methods and some of the practices we're using in our apiaries to create a more generative practice of apiculture. Okay, so before I let you go and drop you into the digital Q&A, I wanted to just show you where you can find all of the downloads that I've been talking about. So this is the They Keep Bees website. This is the newsletter pop-up. You're going to go to the beekeeping tab and you're going to click Queen School. This is that image that you saw in my presentation. It says Generative Bee School Queen Rearing Series. Here is all of our research. You can download the multimedia guide to queen rearing by clicking here, and it'll open up a new tab. Every single page of this document has videos that you can click on, and it'll take you over to YouTube where you can watch hive inspections, where you can watch us make a cell raiser. Oops, that's silly. Where you can really get into every single one of the different steps and methods. So we'll take you from selecting from a breeder queen to making a cell raiser to separating out 48-hour cells. We'll also take you through the process of separating queen cells and making mating nooks. So every yellow box you can simply click on. They'll take you over to YouTube where we will show you a step in the process. All of these videos are recorded with Anarchy Apiaries and They Keep Bees, and all of these videos are captioned, and all of these videos take you step by step through the process. We're using, auditory teaching as well as visual teaching and pop-ups. So really trying to make it accessible for you to work with this stuff in your own apiary. And then if you are primarily interested in runaway splits or walkaway splits, the next tab takes you to our runaway split recipe, where you can watch a video of how to make a runaway split. There's Anarchy Apiaries Southern Outpost. Oops, I did it again. And you can also go through our queen rearing methods field data results, right? So you got up close and personal information about each of the factors that we saw impacting walkaway splits. You can find that on this page. You can get Sam's beekeeping survival guide from our Google Drive right here, which you can print and fold yourself. Tells you all about the comfort hive, walkaway and runaway splits, how to make the inside of a comfort hive, what the origins of the comfort hive and the skep are, and a timeline of beekeeping history, which is really cool. So all of it is free. None of it is, all of it is free. It is completely accessible. And all of the classes that we are hosting online are free. And if you want more about our queen research, our friend Hannah over at the University of Massachusetts made this beautiful illustration of all of the methods that we used. And I referenced this in my presentation as well. So use these resources. Now is the time for many of you, especially if you're in the Northern Hemisphere, to start planning for the upcoming season. And if you're in the Southern Hemisphere, you're winding down and you can start thinking about what you want to try next year. So it's a great opportunity to get on those resources. And if you want to sign up for Queen School, you can come right here, hit this link, and you get a little Google form where we ask you to give us some information and sign up. You only have to do that once. You don't have to do it more than once. And provided you do, you will get information about all of our classes as they roll out. So I'm going to stop there. I really want to just appreciate everyone for coming. I want to appreciate everyone's patience who came to the live version of this presentation, because there was a lot of technical chaos. And I just want to say that, we're beekeepers, we're queen producers, we're scientists, and we're writers, and we're culture holders, and we're not Zoom technical magicians. So thank you for your patience as we learn together. Thank you for being in this with us and being excited about building a different culture of queen rearing. And thank you for trying something new with us and taking risks and having it be, weird or complicated sometimes. Folks really stuck with us to the end. And they really asked a lot of great questions. And so I'm going to link those questions in another hyperlink so you'll be able to hear what folks were curious about, and you'll be able to hear some of my answers and perspective. Finally, I just want to mention that we have 2 more online classes this year. The first is on March 21st at 7 p.m. Eastern Time, and it is called Queens as Seeds. It's with Melanie Kirby from Zia Queen Bee's Farm and Field Institute. And the next is Systems of Instrumental Insemination and Queen Production, and that is with Megan Mahoney from Mahoney Bees and Queens. Megan is an instrumental inseminator. She does queen rearing very different than us. We do open mating, and so it's a cool opportunity to hear a different perspective, and I invite you into that because I think we all have something to learn from each other. All right, y'all, I will see you at the next one in March and at the next one after that. And hopefully you'll be hearing from us in your inboxes real soon about what hands-on enrollment is going to look like for 2022.